The Helix portable ventilator is designed for use in areas where there are limited or no compressed medical gases and where electrical supplies are unreliable, intermittent or non-existent. The Helix ventilator is a gas-driven ventilator suitable for adult and paediatric patients. It can be used for post-op or for longer-term ventilation in ICU. The bellows are mounted vertically and driven by a pneumatic piston. The tidal volume is controlled by turning the Helix screw on the top of the bellows and reading the setting here. There is an on-off control with a power-on light. When the ventilator is switched on, initially all three lights show. The power light remains on continuously and a low pressure alarm remains on until there is pressure in the circuit. There is a patient pressure control valve that can be adjusted by turning clockwise to increase pressure and anti-clockwise to decrease pressure. The patient pressure can range from 8 to 50 centimeters of water pressure, which is indicated on the gauge fitted to the top of the Helix screw. There is a breaths per minute control that will provide a rate from 6 to 40 breaths per minute by simply turning it to the desired setting, and a triggered breathing control to assist recovery after ventilation. There is an alarm for high pressure and a low pressure or disconnect alarm, with a mute for the audible low pressure alarm. There is a circuit block fitted to the side of the Helix ventilator. The gas flow in the circuit works by entraining air through the one-way valve at the back of the reservoir block. This is either controlled by the patient's own inspiratory effort when spontaneously breathing, or by using the self-inflating bag or mechanical ventilation when required. The circuit provided is single-limb circuit connected to a patient valve. This connects directly to the circuit block. Also connected to the circuit block is a silicon tube connected to a self-inflating bag for manual assisted ventilation if required. Expired gases leave the patient valve, which can have PEEP and be applied at this point, 0 to 20 centimeters water pressure. The gas used to drive the ventilator is recycled to ensure there is no waste of oxygen and is put back into the inspiratory valve via the recycled tube. Additional oxygen can be added to the inspiratory valve by disconnecting the recycled gas from the ventilator and connecting it to a supply from a suitable oxygen source. A 1-litre reservoir bag is fitted to the bottom of the circuit block to store oxygen during the expiratory phase of ventilation. There is a battery charge point fitted to the base of the ventilator, which should be connected to the mains power when in use. If power failure occurs, then the internal battery will provide backup for over 100 hours. The adult and paediatric ventilator was initially designed to work alongside the Diamedica portable anaesthetic systems range. If a model from the Diamedica portable anaesthetic range is being used in conjunction with the Helix portable ventilator, then the circuit block is removed and the ventilator outlet is simply connected to the DPA inspiratory valve in place of the self-inflating bag. To set the initial patient pressure, run the ventilator while occluding the patient valve outlet. Adjust the pressure control until the desired pressure on the gauge is shown. Internal battery will run for 100 hours without the need to recharge. To recharge the battery, connect the mains charger here. It will accept any voltage from 100 to 240 volts, and there is also a 12-volt charger supplied. The ventilator can be driven by any gas supply from 1.5 bar 20 psi to 5 bar 75 psi. If a suitable oxygen concentrator is used, the drive gas tube can simply be connected directly from the concentrator outlet to the drive gas inlet on the ventilator. If the gas source is from an oxygen cylinder, the drive gas tube is connected to the cylinder 4-bar regulator. If oxygen is the drive gas, it can be recycled into the patient circuit to increase the FiO2 through this tube from the drive gas outlet to the circuit block. If no oxygen source is available, a compressor pump using air can be used to drive the ventilator. The compressor pump contains a pump, small reservoir, and a lead-acid rechargeable battery and water trap. The inlet filter is first screwed into place and the drive gas tube connected between the pump and the ventilator. The pump is then switched on. The battery should run for 20 hours when fully charged.